curve sketching. So today we're going to sketch y cubed minus 2x squared plus x minus 2 using the curve sketching algorithm. There is a curve sketching algorithm in the textbook. I use a slightly different algorithm. We're going to go through those steps. It's up to you which method you want to choose. So step number 1 is going to be to find the x and the y intercepts from the original function that was given in the question. So obviously the y-intercept would be at the point 0, negative 2. And for the x-intercept, we have to let y equal to 0 and factor. You might have to use factor theorem for some of these, so make sure that you review that concept. But for this question, we can factor using grouping. And we do notice that the first factor, x squared plus 1, has no solution. And the second factor is going to give us an x-intercept of 2, 0. So we're going to hold on to those two values, 0, negative 2 as our y-intercept, and 2, 0 as our x-intercept. And those will be the first things that we plot when we start to graph our curve. So our second step is the first and the second derivative to find our critical points. So by using the first derivative, which is 3x squared minus 4x plus 1, we're going to let that equal to 0, factor, and solve. So we get two solutions, 1/3 and 1. So these are our possible max-min points. They might not be max-mins, but they could be. So those are the values we're going to check. And then you're going to find the second derivative, which would be 6x minus 4. Let that equal to 0, and we get 2/3. So 2/3 is our possible inflection point. And just as a quick refresher, our inflection point may or may not be a change in concavity. So that's when the graph would go from being concave down, N-shaped, to concave up, U-shaped, or vice versa. So what I then do is I take those three values, 1/3, 2/3, and 1, and put it into one giant chart that you can see here. So I go from negative infinity to 1/3, 1/3 to 2/3, and 2/3 to 1, 1 to infinity. So negative infinity to infinity is the domain of our cube function that we're trying to sketch here. So you want to keep that in mind for these questions. And then 1/3, 2/3, and 1 are the points that we found in the above concept, but in order. So that's why you go 1/3, 2/3, then 1. So on the left-hand side here, I identify my original function, the first derivative, and the second derivative. So for my original function, you want to find where you would plot that point. So x would be 1/3, y is approximately negative 1.852. And you can use approximations here because you're just graphing, so you need to know where to put that point. If you substitute x is 2/3 into the original equation, you get negative 1.926. And if you substitute 1, you get negative 2 as your height for that point. So then I have picked a value between negative infinity and 1/3. I've chosen 0. So I substitute 0 into my first derivative. I get a positive value. And then I substituted 0 into my second derivative, and I get a negative value. So that means the function is increasing, but it's concave down. So the shape that is increasing but concave down is this shape here. So our cube function is going to go from negative infinity to 1/3 in this shape. So then I substituted 0.5 into my first derivative and got a negative. Substituted 0.5 into my second derivative and also got a negative. That tells me that the function is decreasing and concave down. So the shape that matches decreasing concave down is this shape here. Then I substitute 0.9 into the first derivative and get a negative, 0.9 into the second derivative and get a positive number. That means that the function is decreasing, but now it's concave up. So this point here was indeed a change in concavity because it went from concave down to concave up. So now decreasing concave up has this shape. And then the last point that we substituted into the derivative was 2. I got a positive. Substituted 2 into the second derivative, got another positive. So increasing concave up is this shape here. Remember, the 4 shapes that you're picking from are over here in a little sketch. We have 2 that are concave down, increasing, decreasing, and then concave up, decreasing, increasing. So those are the 4 shapes that you are picking. So we know that our cube function is going to increase with this shape and then decrease. So that makes this point a maximum. And then it's still decreasing, but it changes its shape because now it's concave up at this point. And then this value here, 1, negative 2, would be a minimum. and it finishes with this shape for its end behavior on the right-hand side. So the next step is to graph. So in order to be super accurate here, I've just opened Desmos. You are expected to be able to graph this by hand, however. So the first thing you're going to do is plot the point 0, -2, which is our y-intercept, and then you're going to plot your x-intercept. And then you want to plot the 3 critical points that we found. So we found 1/3, -1.852. That was our first derivative solution. Our other first derivative solution was 1, -2. And then our possible inflection point, which we then found out in the chart was indeed an inflection point, is 2/3, -1.926, which is there. So then we need to connect these points. So we know that it's going to have a shape that matches the one from the graph there, and then connect those two, and then the change in concavity, and then increase to our last point. So you connect all those points with the appropriate shape, and your function will look like this. So that's our graph of the function y = x³ - 2x² + x - 2.